Hi, myself DEVI, Assistant Professor, Department of AML, Hindustan College of Engineering and Technology. Today I discuss about stack and queue in data structure. So the following contents are discussed: introduction to data structure, define stack and stack representation, stack implementation, define queue and queue representation, queue implementation, and finally summary. So first of all, we discuss about data structure definition. Data structure means that store data in a linear order. One more is non-linear. Linear means it is sequentially stored data. Non-linear order means it is not a sequential. So linear data structure, there is a types stack, queue as well as array. Non-linear means tree and graph. So the application of linear data structure is compiler design, scheduling, and finally memory management. So first we discuss about what is a stack. A stack is a linear data structure where elements are stored in the LIFO principle. LIFO means last in first out, where the last elements inserted would be the first element to be deleted operation. So the operation of the stack means push, pop, peak is empty. Push means add element to top of the stack. Pop means remove top element in the stack. Peak means get top element without removing. Is empty. Check if stack is empty or not. Then stack real-time example, stack of plates, undo functionality in editor, browser history, then stack of books. These are some example of the stack. So the next one is we discuss about queue. So in the queue means, so definition of the queue. A queue is a linear data structure where elements are stored in the FIFO principle. FIFO means first in, first out, where the first elements inserted would be the first element to be accessed. Operation of the queue means NQ, DQ, peak is empty. So NQ means add element to front of the queue. DQ means remove element from the rear. Peak means get from element. Is empty means check if the queue is empty or not. Then queue real life example, people in line, printer queue, customer service system. Next we discuss about representation of queue. A queue can also be implemented using arrays, linked list or pointer. We implement queue using a one-dimensional array here. Here there is a top, we say it is the front, at the end we say it is the rear. In the front we have to insert a data, that is NQ. In the rear we have to delete it, that is the DQ. This is the flow of the queue operation. So in queue implementation there is a 3 array base, linked list base and queue use cases. Array base means it is a circular array to utilize space. Linked list base means pointer to front and rear. Queue use cases: CPU task scheduling, breadth first search, buffer in networking. So till now we discussed about what is stack and stack implementation, operation of stack. So the next we discuss about queue representation and queue implementation. Now we discuss about stack versus queue comparison table. So in the comparison table there is a few feature, stack and queue. Feature means insertion. In stack that is the top of the element. In the queue there is the front. In deletion, in the stack top of the element, in the queue rear. Use cases: recursive, undo. In queue, scheduling as well as breadth first search. So overall we discuss about stack and queue. finally we go for summary. Stack means it is a last in first